more like the right size for us. Classroom. The pretest is already on Google Classroom, right? Where's Mika?
On the golf. Went to the golf.
Hey, Mika.
Yes, sir.
Jason?
Yeah.
Oh, you have. pretest?
I'm doing it.
Okay. You want to start? Today's topic is on drive axles, and by drive axles meaning we explore anything from the transmission all the way to the tire. Okay, and that's going to involve what is called a differential. And differential is that mechanism to split the power or the torque to both drive axles. And we know, you probably know why we need differentials. Anybody knows?
Traction, to gain traction.
To gain traction for both wheels, but why do we need a differential? Why not just connect them together?
So, for example, when we are turning, so the inner wheel turns less than
Right.
the outer.
They rotate at different velocity. Now, however, just a regular open differential, which we'll see, still have issues because there is another need for some kind of connection between the two. Okay, it's called a limited slip differential, because the problem with open differential is that when one tire is hanging, literally there is no torque going to the other one. Okay, so we'll see the kinematics of these things.
Alright, these are the videos we'll go through.
Okay, volume.
And the main function of the differential is to allow these wheels to turn at different RPMs while receiving power from the engine. Consider these wheels, which are negotiating a turn. Clearly, the left wheel has to travel more distance than the right wheel, which means that the left wheel has to rotate at a higher speed. If these wheels were connected using a solid shaft, as shown, the wheels would have to slip to accomplish the turn. This is exactly where a differential comes in. The ingenious mechanism in a differential allows left and right wheels to turn at different RPMs while transferring power to both wheels.
Okay, so if you just need to split or transfer the torque in a 90-degree way, then you'll just use this bevel gear, right? 90-degree transfer, done. But here we need to split the left axle and the right axle. So you see the split here, right? You see the gap? Okay, so that gap separates the left axle and the right axle. However, it is still linked using the spider gear.
Step by step, we will learn how a differential achieves this feat, using its simplest configuration. Power from the engine is transferred to the ring gear through a pinion gear. The ring gear is connected to a spider gear, which is at the heart of the differential. The spider gear is free to rotate in two different ways. One, along the ring gear, and two, on its own axis. The spider gear is meshed with two side gears. So power from the engine flows from the pinion to the left and right wheels, as shown. Now, let's consider different cases. When the vehicle moves straight, the spider gear rotates along with the ring gear, but it does not rotate on its own axis. The spider gear will push and make both side gears turn at the same speed. When the vehicle is moving straight, the spider side gear assembly will move as a single solid unit.
So they just move together. There is no relative rotation, okay? When both wheels are at the same speed. And it is only showing one spider gear just for the sake of visualization. But in actuality, there's two.
Now, consider the case when the vehicle is taking a right turn. The spider gear plays a pivotal role here. Along with the rotation of the ring gear, the spider gear spins on its own axis. In fact, the spider gear is forced to do this second spin to meet the demands of the right and left wheels' different speeds.
So it's not that it's rotates with a torque. It's forced to rotate because of the difference. So in a way, the spider gear actually just allows for this different RPM, left and right.
So the spider gear is having a combined rotation. The effect of combined rotation on the side gear is interesting. When properly meshed, the side gear has to have the same peripheral velocity as the spider gear. When the spider gear is spinning and rotating, the peripheral velocity at the left side of the spider gear is the sum of spinning and rotational velocity. However, on the right side, it is the difference between the two. The left side gear will have higher speed compared to the right side gear, which is how the differential manages to turn left and right wheels at different speeds. While taking a left turn, the spider gear will spin in the opposite direction.
Okay, you see the different speed? Okay,
In
left
order
and
to
right.
carry load, one more spider gear is usually added. 4 spider gear arrangements are used for heavy load vehicles.
So you can have 4 if you want.
Apart from allowing wheels to rotate at different RPMs, the differential has 2 more functions. The first of these alternate functions is speed reduction at the pinion ring gear assembly, which will result in torque multiplication. The other function is to turn the power flow direction by 90 degrees. The differential we have gone through so far is known as an open or standard differential.
This also exists for the front wheel drive. Okay, I mean we're looking at the rear wheel drive for better visualization, but in actuality you will still have this split even with the arrangement of, so if this is the car, front wheel drive transmissions are this way, right? So engine, crankshaft. Now at the output here, you have the drive axles, right? There is still a differential there, even though it's just a different arrangement. Okay.
It is capable of turning wheels.
It's not a bevel gear arrangement, but there is still the same concept of the spider gear.
At different RPMs, but it has one major drawback. Consider a situation where one wheel of a vehicle is on a surface with good traction and another wheel is on a slippery track. In this case, a standard differential will send the majority of the power to the slippery wheel, so the vehicle won't be able to move.
Okay, so this is something interesting. Can you guys imagine this? Why this is happening? Why is it that when the right wheel loses traction, the majority of the torque actually goes to the right?
The spider gear is forced to move the other half, which has less resistance. This one
Okay.
has more resistance, so it's gonna force the opposite way to move.
So the spider gear is actually free to rotate, right? So when you have these two side gears, okay, so you have these two side gears, left and right, and then you'll have the spider gear here. Now, the spider gear is actually free to rotate on its bearing, obviously. And when this is stationary, okay, think an extreme case. Think of an extreme case where the wheels are literally off the ground on this wheel, but this wheel is, stick slidable, like purely fixed. Now, in this situation, if you're rotating the spider gear this way, what will happen? Let's say this is like, literally I bolted this to a wall, okay? Like this is an extreme situation. This is bolted to a wall, so it cannot move. Can your engine or transmission can still drive the entire thing? Will your transmission lock? No, right? Because this is free to move. And what will happen if this is literally bolted to the wall? It's gonna basically move this guy. Okay? Basically, this is the only wheel that is rotating, and this stays stationary, and that's fine because this thing is free to move. Now, because of this, everything, 100% of the torque basically goes to this guy, and that's the problem with open differential. We have open gutters in Indonesia, right? Don't know whether you have actually experienced your wheel actually drop to the gutter and hangs in the air. You know what I mean by open gutter, right? Do you have open gutter in Mauritius? No. So my parents still live in Jakarta. I live in BSD, but we still have open gutters in front of our house. And so if you're not careful, you can drop and your front wheel, like say your right front wheel, hangs in the air. In that case, you're done, right? Because first of all, it's a front wheel drive, it's not all wheel drive. And once it hangs, what will happen to the wheel that is on the ground? Nothing, right? This thing is not getting any torque. All the torque goes to the wheel that is literally floating in the air. And so this is a problem. Because in that situation, where do I want the torque to go? To this one, the one on the road, obviously, right? Because I want to get myself out from the gutter. That's a problem. In fact, even when your like a racing situation. Let's say you have different downforce, like during turns, right? So let's say the normal force, N1 versus N2. Let's say the normal force is bigger here because you're turning this way, right? You're going into the board and you're turning left. So this has majority of the normal force, which means this has better traction. Where do you want the majority of the torque to be? This one, this one. If this has better traction. This one, right? Obviously. But this one will slip first. Maybe some micro slipping, not a full slip, but some tire slip. And if they have just a little bit of a slip, the torque will be bigger here, which is the opposite of what we want, right? So this becomes a real problem, even not in the accident situation, but even in racing situation. And so in off-roading, this is also very, very relevant, right? Because again, you'll have different, your normal force will vary because your terrain is all over the place. And so you'll have many situations where the left and right wheel does not get the same traction, whether it's hanging a little bit, less downforce, or puddles, whatever, right? Puddles like that. And so in all these cases, you want at least equal torque, okay? If not, maybe some transfer, at least partially, you go here more, okay? So this becomes a real problem, and that's where LSD comes in.
To overcome this problem, limited slip differentials were introduced. We will learn more about those in a separate video. Please.
Okay, so let's go there.
Consider a situation where a vehicle fitted with the standard differential moves straight, and one drive wheel are completely independent. Since one wheel is on a slippery track, the standard differential will make the wheel spin in excessive speed, while the good traction wheel will remain almost dead. This means high power supply to the slippery wheel and low power flow to the good traction wheel. So the vehicle won't be able to move. One way to overcome this problem is to limit the independency or relative motion between the left and right axles.
Okay, so here's the key. Here's the goal in limited slip differential. Remember how this is totally separate? So there's nothing here, right? So now we're gonna somehow connect them, but we need to connect them in ways that is not fully welded, right?
Limited slip differentials are introduced for this purpose. One of the most commonly used LSD technology is clutch pack based. First, let's go through its constructional features. Apart from its basic components, a limited slip differential has got a series of friction and steel plates packed between the side gear and the casing. Friction discs are locked with the side gear. So the friction discs and the side gear will always move together.
Okay, notice the color. The blue one rotates with the axle. Again, this is a multi-plate clutch style, not a single plate.
The steel plates are having external tabs and are made to fit in the case groove, so they can rotate with the case.
Okay, so orange rotate with the case, the blue rotates with the axles, and the case is on the outside.
If any of the clutch pack assembly is well pressed, the frictional force within them will make it move as a single solid unit. Since steel plates are locked with the case and friction discs with the side gear, in a well-pressed clutch pack, motion from the casing is directly passed to the corresponding axle.
Okay, so the case turns.
Space between the side gears is fitted with a preload spring. Preload spring will always give a thrust force and will press clutch pack together.
So in this case, the clutch pack is constantly pressed partially, not fully, but partially. Okay? So we cannot connect them here because there is no room. So we use a case, right? So there is a case connecting the two, but the case and the shaft is partially connected, right? Now, you thought to yourself, okay, well, the clutch pack, isn't that going to be worn out very soon? Yes or no? When do you see the clutch pack rubbing against each other? Is it all the time? No, right? When will the clutch pack have relative friction or motion?
Sleeping.
Only when?
Once it's sleeping.
Okay. Yes, when it slips, but to be precise, when does the clutch pack has relative motion? When the RPM of the left wheel is not equal, right? So only when the RPM of the left wheel is not equal to the right wheel, then there is some slippage, right? Otherwise, they just move together, no problem. So, the clutch pack is not even used most of the time when you're going straight.
You can note that spider and side gear are bevel gears. It has got one specialty. When torque is transmitted through a bevel gear system, axial forces are also induced, apart from the tangential force. The axial force tries to separate out the gears. You can note that side gear and axle are two separate units. The side gear has got a small allowance for axial movement. So during high torque transmission through spider side gear arrangement, a high separating thrust force is also transmitted to the clutch pack. This force presses and locks the clutch pack assembly against wall of the casing. Now back to the initial problem. Since one wheel is on a high traction surface, the torque transmitted to it will be higher. So the thrust force developed due to the bevel gear separation action also will be high at that side. Thus, clutch pack at high traction wheel side will be pressed firmly, and clutch pack will be locked.
Okay, so what is this saying? So the friction plates, the pressure on the friction plates is not constant, right? At low speed and at high speed, what's the difference? What happens at high speed?
Moves freely. It moves freely.
Well, actually, this thrust force will be greater at high speed. So, when one wheel spins faster, it's going to press the clutch pack on that side. Okay? So, the speed is actually going for our advantage. So, there is the effect of the speed to the outward motion to this clutch pack, which then presses it the way we want it, right? So consider a situation where it is extreme, where one wheel actually hangs on the air, and then you press on the gas pedal, it's going to spin very fast, right? While the other stays still in the open differential. Now, when you have the clutch pack, when this spin very fast, it's going to attach itself to the clutch pack and transfer it to the other one. So this speed is actually going in our the way we want it, right?
So power from the differential casing will flow directly to high traction axle via clutch pack assembly. On the other hand, clutch pack on the low traction wheel side is not engaged yet, so power flow will be limited to that side. So the vehicle will be able to overcome the traction difference problem. However, while taking a turn, the LSD can act like a normal differential. In this case, thrust force developed due to bevel gear separation action won't be that high. So the plates in clutch pack will easily overcome frictional resistance and will be able to slip against each other. Thus, the right and left wheel can have different speed, just like an open differential.
Okay,
Following are the other.
so you actually transfer all the way out here. Okay? So this clutch pack, when it connects, it actually transfers, it skips the differential and actually transfers the torque all the way out here, because there is some sliding action here, right? So you will not actually hold this in place, it skips that and directly rotates that. Okay? Now, there is another type of differential that is really smart. It's called the torsion. It's developed by Audi.
Use technologies.
It's developed by Audi, and let's see how it works. It's really it's a bit complicated. I'm going to be honest with you. Some detail of it I'm still trying to visualize, but this is amazing.
Torsen is a trademark of the JTEC Corporation. The Torsen differential has many patented components and is the most unique and ingenious method of providing differential action while overcoming the traction difference problem. The internal components of a Torsen are quite different from that of a conventional differential. At the heart of the system lies a specially shaped gear pair assembly. Let's see the cross-sectional shape of these gears at the mating point. As can be seen, one gear is a spur gear and the other one is a worm gear. A Torsen works on the simple principle of worm gear, worm wheel. That is, a spinning worm gear can rotate the wheel, but the rotating wheel cannot spin the worm gear.
In gear terminology, this is called, it's not back drivable. It's like this can drive that cannot drive this. If you want to imagine an extreme example, this is a bit hard to imagine, but consider an extreme example, right? So, in this case, you rotate this, it's going to rotate this very slowly, right? But the more extreme the ratio, and the more not back drivable it is, right? So, this will basically just halt. So, this A can drive B, B cannot drive A.
Throughout this discussion, just keep this principle in mind. A pair of such worm wheels are fitted with the case
so the engine power received by the case is transferred to the worm wheels. Each end of the wheels is fitted with a spur gear. Now let's consider different driving scenarios. When the vehicle moves straight, the worm wheels will push and turn the worm gears, so both the drive wheels will rotate at the same speed.
Okay, so this is easy to understand. It's the same as the open differential.
Please note here that, in this condition, the worm wheels do not spin on its own axis. In this condition, the whole mechanism moves as a single solid unit. When the vehicle is negotiating a right turn, the left wheel needs to rotate at a higher speed than the right wheel. This speed differential is perfectly supported in the torsion. The worm gear of the faster left axle will make the corresponding worm wheel spin on its own axis. On the other side, relative to the case, the slow right axle is turning in the opposite direction. Thus, the right worm wheel will spin in the opposite direction.
Okay? Mind juggling a bit. Okay? So the
Worm wheel will spin in the opposite.
because the relative of this motion, this axle to this axle, is like opposite, right? If you're standing on this, you'll see this actually rotate the other way. It's like, do you ever experience this? Like you are parking the guy next to you backing out, and you thought you're going forward because you thought, oh, we have relative motion, right? So this is the relative motion, which then creates that rotation on the blue spider, or usually spider here.
It's a direction. The meshing spur gears at the ends of the worm wheel will make sure that the worm wheels are spinning at the same speed. Thus, it guarantees a perfect differential action. Now let's try to understand how the torsion overcomes the drive wheel traction difference problem. As you might be aware, when your vehicle encounters a situation as shown, the slippery wheel starts to spin very rapidly and will draw the majority of the engine's power. As a result, the vehicle will get stuck. But if a torsion differential is used in this case, as soon as the slippery wheel starts to spin excessively, the speed change will be transferred to the worm wheel. The right worm wheel transfers the speed change to the left worm wheel, since they are connected through spur gears. Here comes the tricky part. The left side worm wheel will not be able to turn the corresponding worm gear because, as we said, a worm wheel cannot drive a worm gear.
In other words, it's kind of locked, right? It's locked. So what will happen? The right blue gear is turning clockwise, which wants to turn the left blue wheel counterclockwise, but it cannot. So what's going to happen? So in the end, it's gonna move the orange gear instead.
As a result, the whole mechanism gets locked, and the left and right wheels turn together. This allows a large amount of torque to be transferred to the high traction wheel, and the vehicle can thereby overcome the traction difference problem.
In fact, it transfers 100%, right? So this is even better than the clutch pack. But the downside of the clutch pack is that there is always some friction between the left and right. Whenever there is slight turns, okay? There is some, not much, but the torsion overcomes this perfectly with no friction mechanisms.
To carry the load, 2 more worm wheel pairs are added. If you are familiar with the other common technologies used to overcome the traction difference problem, you might have noticed a great advantage of the torsion. While the other technologies allow the drive wheel to slip for a limited amount of time before it gets locked, in torsion, the locking action is instantaneous. That means, as soon as the vehicle encounters a traction difference track, the wheels will get locked. To know more about the clutch pack LSD technology, please check the next video.
So, in fact, you put this torsion basically puts the friction or the traction or the torque to the one with the good traction. So, awesome technology. And people say this is why the first time the torsion came out, the Audi won the rally championship. Even though Subaru follows along really tight. Who follows rally? No. I don't watch rally myself, but I heard about it. Okay? Now, there are ways to actually accomplish this electronically now that controls are getting better. So, in the old days, what makes mechatronics powerful? It's because chips are getting faster and cheaper. And so that is the revolution that makes controls and mechatronics possible today. Okay? So this is
With its electronic limited slip differential technology, Dana is building on its driveline expertise and expanding its influence as a system solution provider.
Well, before we actually see how it works, make a guess. If you want to control this coupling between the left and right electronically, how will you do it?
IAS sensors.
Okay, you will have sensors. So obviously, you have to monitor the difference in RPM.
Actuator in the differential.
How would you actuate it?
Hydraulic or pressure or mechanical pinion.
So obviously a magnet might not be sufficient, so you'll have to go hydraulics, right? Magnetic coupling is probably adequate for AC compressors, and that's the click you hear whenever your AC compressor comes on. Click, the magnet grabs the pulley and rotates your compressor. But these are much higher torque, so you'll have to use
Our light vehicle division covers all platforms in the passenger car, crossover, and SUV categories. One of our latest innovations bridges the gap between a full all-wheel drive system and a two-wheel drive open differential system, surpassing the performance of a two-wheel drive open differential unit without the added cost and inefficiencies of an all-wheel drive system. Dana's ELSD technology delivers maximum tractive effort while improving drivability, and it corrects unwanted driving behaviors such as oversteer or loss of traction in a fraction of a second. Utilizing proprietary software to determine optimum torque corrections, it analyzes data from a number of sensors, calculates the required traction, and distributes torque to enhance handling. The control unit monitors vehicle parameters over the vehicle CAN bus to gauge when a wheel spin is imminent. A signal is then sent to the electric motor, which spins up and drives a ball ramp through a gear ratio. The ball ramp loads a clutch pack to limit the speed difference, transferring torque to the wheel with good traction. This technology is a bolt-on solution for any front-wheel drive transaxle or rear-wheel drive rear axle.
So basically you can do whatever you want, how much the percentage distribution that you want. Now it mentioned in the beginning of the video about oversteer. You know what oversteer means? And understeer? So this is the turn. An oversteer what does an oversteer do to your car? Where are you going to crash? To the outside, okay? So this is oversteer, okay? And understeer is, what happens in an understeer?
When you turn, but doesn't go to the right.
The rear end actually swings, and then you end up crashing this way. Okay? So understeer does that. While oversteer, you basically go straight instead of a turn. And they call it over because you steer over the radius that you actually want, right? Because the front wheel is the one slipping. So you have front slip, and understeer you have rear slip. Now, how will this help your oversteer situation? Front wheel drive cars are very much oversteer. Front engine, front wheel drive, front heavy. It's really bad oversteer, right?
Sorry, is it not the other way around? Is it the other way around? Oversteer is when you spin out, right? If you're understeering, then you turn to the direction you want to go, but you go straight.
It's like in F1 you when you turn
terminology.
Yeah, sorry. Drink my coffee today. Okay? So huge understeer in front wheel drive. How will this LSD help us? If it's up to you that you can distribute any torque anywhere you want, how can you correct this? Say on the understeer.
So usually if you're turning, the corrosion will be like this. So more contact and
Yes.
surface here. So most likely you're gonna want more torque here to be able to overcome the inertia of the car.
So basically you are able to force the car to turn, right? By reducing the torque here. So this is a very powerful tool.
Similar to Dana's disconnecting all-wheel drive technology, it disconnects when not in use to maximize efficiency. The LSD can be preemptively engaged in situations where wheel slip is likely, such as starting from a stop in icy conditions, or accelerating from an intersection around a corner on a slippery surface. An ELSD improves over a passive limited slip by controlling when the unit biases torque. If the controller determines wheel speed difference is appropriate, like in a low-speed turn, the unit will not be activated, allowing for easy maneuverability. But when the wheel speed difference is excessive, the unit can be engaged to improve mobility and handling. Since it is only activated when needed, ELSD won't adversely affect handling like a passive LSD can. Today, Dana is bringing greater performance and mobility to the light vehicle market.
So basically you can force however you want it to be, even though there is no difference in omega, in RPM. So very powerful. And in fact, in a lot of the EVs, if you have independent motors, that's what you have. I mean, you can basically vary it however you want, and the handling becomes even better. Okay? So awesome technology. I'm sure it's expensive. So you will not see it on your Honda Brio or your Avanza, I don't think. But that's going to be fun. Okay, now before we go to the CV joint, I want you to
The tripod joint for the drive shaft, which transmits the driving force of the engine to the wheels, stably transmits the rotational force.
Okay, so this is a drive shaft. It's basically connecting to the wheel, right? But why do we need certain joint? Why do we need certain joint, certain universal joint when connecting the transmission to the wheel?
Because of potholes at right height.
It's moving up and down, so your axle cannot be just straight, right? Horizontal. But you can make them move together, which is the old design, you know. The other extreme situations is in front-wheel drive. Because in front-wheel drive, it's not just the motion up and down, but you are turning and accelerating at the same time, which is usually when your CV joint burns out. That's when you hear it the most, right? You turn, you make an extreme turn, press the gas pedal, and you hear the right? And so, you know, all that comes loose or dry. Now, before CV joint, what do people use when you want to have an angle and turning? Yeah?
U-joint.
It's called the U-joint. Now, to make this a little bit interactive, why don't you do a little bit of a search about U-joints and what is the problem with U-joints?